culture, the ability to run at super speed seems like one of the best superpowers to have in the world. You get to places super fast, you don't have to worry about knowing public transit anymore and smell the smelly old homeless guy next to you. You don't have to worry about gas money or even a car. Plus, superheroes like the Flash and Quicksilver make it seem like you can do good in the world and save the people you love. Like, save a couple people from car crashes, save an entire school from an explosion, or stop a terrorist before he can detonate his own bomb. But once you start to break down the physics of these characters, once you start breaking down the physics behind super speed, you start to realize it's a terrible power. The amount of lethal force that's being applied on your body, the amount of food that you actually have to consume on a daily basis to maintain the speed, and the potential lethal injuries that come with super speed, you may start to think twice of actually wanting super speed in the first place. Alright, let's start off easy. How much force is needed to accelerate you to, let's say, 2 times the speed of sound, or around 686 meters per second? We're going to assume that you can accelerate to that speed just like how a normal person can accelerate to the running speed, or around 0.1 of a second. So plugging it into the BF, the initial, plus AT formula, you get the acceleration around 686 meters per second, or around 700 Gs of force, which is probably enough to kill you or at least knock you out. It's more than what a fighter pilot experiences when they go under a dive or something like that. So if the G-force didn't kill you, the amount of force that's being applied on your body might. So assuming that you're a 70 kilogram man and you accelerate at 686 meters per second squared, the amount of force on your legs are approximately 4.8 times 10 to the 5th newtons of force. For context, it takes around 4,000 newtons of force to break your femur. So if you're running at that speed, that's more than 120 times the force needed to break your femur. So realistically, if you go at super speeds, at an instant your legs are broken, and you'll probably be lying on the ground, crying in pain, or if you touch someone else, you're probably gonna break their bodies because of the amount of force that you apply on them, or possibly even kill them. But once we start to plug in air resistance, it starts to get a little more insane for us. So assuming that we're running at sea level and we find out the values for the coefficient of friction, or the drag coefficient, the area of the object the human might possess, and the density of air around us, we get the air resistance around us to be around 1.91 times 10 to the 5th newtons of force. For context, that's approximately the same amount of force an F-16 produces at full afterburner, which you can imagine is probably not that good for you and may or may not blow your head straight off your shoulders. So don't do that. So combining the amount of force needed to go 686 meters per second plus the force needed to battle air resistance, you approximately get around 6.71 times 10 to the 5th newtons of force, ignoring static friction, kinetic friction, and any other factors like the drag caused by going at Mach speeds, because those calculations are too complicated for me to battle alone. And that amount of force is enough to break steel. So if you run at that speeds, you're more likely to just shatter the ground below you and probably just get stuck underneath it, as you can see in this clip. Also, if you go on Mach 2 speeds, the amount of kinetic energy you produce is around 24,000 joules of energy, which is around 12 times the amount of kinetic energy a bullet produces, which is around 2,000 joules of energy. Also, one thing that people tend to forget about running at Mach 2 speeds is that, what if you get hit by an insect or a bird? Well, in this calculation, I calculated how much force getting hit by a common housefly would be like, and it's equivalent of 50 pounds of force. Imagine running at Mach 2 speeds and getting hit by a fly and getting knocked clean out of your feet. That's gonna hurt and be extremely embarrassing. Okay, but here's the big question. How much energy do you need to eat in order to reach Mach speed? here's how you're going to do it. An average man burns around 100 calories per mile run. So we're going to use one of our kinematics equations, the d equals v initial t plus 1 half ac squared, to help determine this. So we're going to assume we run for 60 seconds and run at a constant acceleration of 686,000 meters per second. And we get our distance travel around 1,248 kilometers, which is about almost the circumference of the Earth for some context. We're then going to convert the kilometers into miles, and we get around 7,643 miles ran. Then we're going to multiply that by 100, and we get around 767,000 calories burned. That's almost 1 million calories. So in order to regain those calories, you're going to have to eat around 1,363.1 Big Macs, or 300 kilograms worth of Big Macs, or alternatively, you could eat 2,398 kimchi cup noodles, which, in my opinion, is way better. And finally, if you move at Mach speed, you're probably going to burn up in the atmosphere because of a thing called adiabatic compression, which occurs because the air around you can't move away fast enough and thus heats up. So your skin heats up as well and burns, just like this corner. So in conclusion, when you run at super speed, you probably won't look like this, and probably look more like
Oh, that car!